This is SIG Scalability meeting, 3rd August 2023. And yeah, I mean, Shyam, if you want, you can start.
Yeah, so I see Nathan is from the AWS side on the call. The first item from last week's agenda is this PR, where Nathan made some improvements to the APF public docs for Kubernetes to kind of make it more user friendly, kind of more as a guide for users to configure their priority levels, like how to get out of issues and that sort of stuff. I'm not sure where it stands review wise. Maybe Nathan, are you still seeking traction from reviewers on this, or?
Yeah, I think it's ready for another follow-up review. I pushed a revision last week. It was mostly around language improvements and formatting. I think it probably needs a content review from someone from SIG Scale or API Machinery. But yeah, that's still pending reviews.
I would be happy to take a look as well for it.
Okay, yeah.
In terms of like content.
Thanks, Marcel. Yeah, that'll help for sure. So the context is you're probably aware of the couple issues around APF that happened with how we did some seat calculation changes, how we changed that calculation, and that kind of affected some customers.
I'm seeing this all the time with our customers as well. So
yeah, so I guess I think the general high-level themes we discussed there is like, well, one thing is this better documentation, of course, for customers to be able to kind of mitigate themselves out of these issues. And the other is how can we make these changes more robust going forward in terms of can we isolate the impact of these changes from affecting other kinds of requests, let's say, because these changes are mostly with lists and watches. Let's say if you increase their seats, the other requests might get fewer seats and cause all sorts of issues. So I guess that is one theme. And
I think like regarding this theme, I think it definitely changes in 126, right? Where the borrowing was introduced, where this should mitigate some of the issues, right? Like if you have like limited concurrency in one priority level, then with borrowing, you're able to borrow from other priority levels, which should improve overall throughput for the same control plane size.
Yeah,
in like regular operating.
Yeah, that makes sense. The other aspect is like, or should we make this configurable on the max cap? Like maybe we haven't fully thought through yet if that is the ideal way of doing this, or if there's a better way. But like be able to configure this cap, like on how many max seats can a list be counted to occupy. So to reduce the interference with other requests. And yeah, I believe, I think from the last call where there's I believe Andrew Sikkim and Wojtek were also there on that call. I think the general sentiment I felt like was not to have this sort of configurability and just us giving good defaults and making sure this works, which I mostly agree with. But yeah, I think for some of the customers, we anyway ended up having to, within EKS, like go patch for the older versions, the max seat calculation, so that they suddenly don't shoot themselves in their own foot after an upgrade. Right. So I guess, yeah, I think for now, we have a plan of kind of gradually increasing this across the seat calculation cap across revisions, also across Kubernetes versions, sorry. But yeah, I think this needs to have a follow-up. We should talk about the other changes that David, you had around list call testing with CL2 and how some of testing improvements can help with these issues. I know you sent a you were looking into an issue with adding list throughput. Do you want to talk about that? The CL2 one?
Yeah, sure. So for I have a PR that to try to add some testing for to exercise the list call. So I have for that PR I have got like first round review, and there's comment I need to address. So once that is addressed, I can ask for another review. I hope I can get to it sometimes next week, early next week. And I have another PR, like trying to improve documentations about APF debug endpoint. So that one, I think is close to get merged, and once I get approval from Mac, it should be able to merge.
Okay. Sounds good. Thanks, David. If you're blogged on reviews or like you need help, there we have at this point at least 3 different reviewers and 6 scale can help you. At least for the CL2 side of changes. For public docs, I think you'll need at least one another person outside SIG. All right, I think that's all the follow-ups from the last call. Does anyone else have anything to add or any issues they want to bring up or questions?
Hi, Shyam. I have some questions for the PR that adjusts the max seat more dynamically. If anyone does not have, I can use the time for discussing that.
Yeah, go ahead.
So the way we are using API priority and fairness right now is to jail the list request. So what we're doing is we've identified certain requests like list to secrets or list to PVCs that have a tendency to the API server, right? Because the number of secrets are huge in our environments. So the way we use API priority fairness is we have specific API flow schemas for secrets, let's say, for an example, and nothing else in that flow schema. It's just a list call to secret. And so all the nominal seats for that flow goes towards serving the list request. And based on rough calculations, we have found out a certain number of requests kill the API server. So considering a priority level that is assigned to that flow schema is less than that kill, we are able to have a rate limiter in place using APNF so that list requests don't kill control plane. So with that background, I was wondering, since we rely on static calculations and max limits, how would that be? How should that be addressed going forward with 1.28 upgrade?
So you're saying how to avoid? So you're saying you made some custom flow schema changes and how to preserve them during an upgrade? Is that your
Correct.
question?
Yes, because here, so what we did was the nominal seat calculation for the API flow that we are using is static. So for example, let's say 10 max seats right now, right? And in that flow, no other requests are being served, just list requests to secrets are being served, list and watch both. So because this change calculates the max seats more dynamically, and it only preserves 0.15 of the nominal seat. I was wondering how would we continue to have the same use case post the upgrade.
Okay, so I guess what you're really asking is if you have to make any changes to the custom flow schema you added after an upgrade to kind of keep up with this behavior, right? Or you're
Right.
saying
Yes.
so you don't make any changes to any of the default flow schema like priority levels, right? You only
Yeah, we
add
don't
your
make
own
any.
ones.
Correct.
So you're not worried about like Kubernetes overwriting existing like default flow schemas on an upgrade, but how to make your new flow schema
Correct.
work. So I believe that is a good question. I think from the angle of, I mean, my understanding is it is possible you can make, you have to do the math again and you have to make the new, with the new version of this flow schema work to kind of get your seats correct. But I think the bigger question probably where you're heading towards is like the usability of this feature across version updates if we are changing the behavior with our seat calculation. If
That's correct.
Kubernetes is
Yes.
changing. So let's do this. Maybe can you on that on this particular PR, can you add a comment there like saying that this is our use case and asking that how can we make sure that across versions these sort of changes are safe to do, or like what do users have to do, because I want that discussion to happen there on that issue since we've been talking thoroughly about it.
Okay, sure.
And we can have other folks chime in too, because Mike Spritzer, Wojtek, I would like to have them chime in on these two.
Sure. And I think I can do that. And I think what will help is coming up with example numbers.
Yeah.
Maybe for the next meeting, I can come up with a sample example
Yes,
and
please.
how it could break with the upgrade.
Sure.
Yeah, and one call out I have, this particular PR is also patched in 125, 6 and 7. So if you are doing like a patch upgrade for the existing clusters, so be mindful that this behavior is now across 125 and 28.
Oh, okay. Thanks. I was not aware. Thanks for the heads up.
Yeah. Oh, another option, maybe once we start discussion, is to consider not recalculating the max seats for custom flow schemas or PLCs, because it can negatively impact, like in this particular case, which LA is pointing out. But yeah, we can
Yeah,
have that discussion in the issue itself.
that's correct. So what I was thinking is that if we have some kind of optional field in the flow schema that would stop the dynamic calculation of max seats, then it could be a workaround to this problem, supporting the older use cases. But yeah, before going there, let's get a consensus whether this is a problem or not on the PR, and we can go from there.
All right. I guess if there's nothing else, we should either move on to the next discussion or wrap up.
Yeah, that's it from my side.
Does anyone else have anything to add? Maybe Pratik, do you have anything in the testing front that you want to share with the SIG?
Yeah. So for in the testing side, we are trying to move the job to the EKS Prow build cluster, and ran into a couple of issues. I'm working with the SIG infra to get those resolved. One was COPS didn't have the permissions to read the S3 bucket that it is already using in those jobs. So we're trying to figure out if we need to create like a new bucket for this new cluster or give permissions to the existing one. So the delay is basically coming from like moving these jobs to the new cluster, but I also made the change for the CNI to
With
enable
the new,
the,
so you said new cluster, new account, you mean?
yeah, it's a new account, but it's named as EKS Prow build cluster.
Oh, I see. Okay.
It's a new account, yeah. And I also made the change for enabling the prefix delegation for CNI, which we were suspecting is the reason for the failure for the jobs, but I haven't been able to test after that since we are in this phase of transitioning to this new account. So once the job starts succeeding in the new account, we'll be able to tell whether the prefix delegation is helping us or not.
Got it. And this new account will be dedicated for
Yeah.
just these scale tests, correct?
Correct, yeah.
Okay. Cool. Yeah. Thanks for helping us drive this work on that front. We can maybe get another update in the next call. Hopefully by then we'll get the help needed to move this account over. Yeah, I think that's all the topics I believe we had from the AWS side. Anyone else? Any questions or asks?
There was one issue I was looking into this week. I don't think upstream issue has been cut yet, but I was looking into this with Abu. I've seen some requests take longer than 15 seconds and get rejected from APF. And my understanding was the longest a request could wait in the queue is 15 seconds. So if something's rejected with 429 from APF, it should be less than or equal to 15 seconds. We've seen examples where it takes between 15 and 60 seconds, which could result in requesting in queues longer than their configured timeout. So it sounds like this is not intended behavior, and Abu is going to cut a issue upstream for this.
So I think like one point of view for that is that, you know, the request is rejected, as you said, like after 15 seconds, right? It should be at least. But how it happens is that the new request needs to be enqueued to this queue to go through, like, you know, the queue of the request. So there's no like any, you know, go routine that is checking, or there's no context timeout. There needs to be another request that is assigned to this queue to go and reject already waiting requests. So this is, I think, like simplification that was made in priority and fairness implementation.
Okay, got it. So it's idle queues that could result in them waiting longer than this period. Do you think that this would be fixed, or
I don't know. I don't know. I
Okay.
also saw this issue before, and at least that was my assumption that this is what can happen because that's how it's implemented right now.
Okay, got it. I think Abu had the same theory regarding this, so it sounds like he was going to cut an issue and then have the discussion there.
Okay, and while these requests are waiting in APF, they do block seats, right, for any other requests that predicate in?
No. The ones that are queued are not being executed, right? And you should get 4 to 9 after like 15 seconds for those requests, but you might not receive try again, because if there is no other request that goes into the queue, it will not reject the one that is waiting. But they are not taking the seats because they are just in the queue.
I see. So they're just basically occupying some memory somewhere and just being sent a 429 after this 15-second period.
Yes, exactly. Yeah, but they are not occupying like a lot of memory, right? Because there is like limit in like the amount of requests that you can have in a single queue.
True. Yeah. So I think the only issue is maybe for client, they wait for 15 seconds before knowing that they have to try again.
Yes, at least they should,
but-
right? They should receive it, but they don't.
Yeah.
Well,
The problem is
would-
we are unable to tell them, like when the requests come within within a few seconds, we're unable to tell for sure that we can't serve you, which is why this 15-second is like a side effect of trying to do that.
to clarify, so clients would be waiting for up to 60 seconds compared to 15 seconds, right? Like I think the trade-off here is we are adding latency onto these requests, even though they're just sitting in queues and not being dispatched.
Yeah, I think there was a discussion, if I'm trying to remember correctly, there's a discussion around measuring the API latency metric without including this waiting in queue duration, so that it doesn't show up as false latency.
Yeah, in
alarms
127,
on-
the SLI metric, I think it doesn't count the APF duration. And the
Yeah,
webhooks.
it doesn't count the APF, I think, and also webhooks, all this kind of stuff.
It was added in 127.
Okay, cool.
But one follow-up question I have is, if the request is in the queue and the client doesn't time out in 60 seconds, will API server time it out in 60 seconds?
Yes, usually, most of the time. And there's another check for each request to time out after 60 seconds.
Because in one particular case, when there is like slow client, that's when it doesn't time out. But in this case, it will still be queued, although the request will be timed out by API server. So is that the right understanding?
I
So
think
let's say,
yes. So I'm actually not sure about this logic, to be honest. I know that there is like another 60 seconds timeout that is totally separate from everything else.
okay.
Yeah, on the examples we looked at, like there was thousands of these requests. The maximum timeout we saw was 60 seconds. So the overall request duration is respected. It's not just in some cases, this 15-second timeout is not. I think we've only seen the 60-second timeout exceeded when API server is writing the response back to the client. And in this case, the request is waiting in the queue. So it shouldn't run into seeing latencies longer than 60.
But it makes sense. So that means if the request is still queued, at least the client is notified in 60 seconds that it has timed out and they can retry.
Yes, yeah.
Got it.
Okay, do we have anything else? Then I guess we can finish. Thank you all for coming, and see you in 2 weeks. Bye.
Thank you. Bye.
Thanks, everyone.
Thanks.